Alright, so today we're doing trapezoids and kites. These are the last two of our polygons. So getting started here, a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So the bases are going to be the bases are the parallel sides, okay? So if we go up here, we'll just copy this word. So the bases are the parallel sides. So here we have the bases are going to be JO and RK. So JO and RK. And we'll line those up. So JO and RK are going to be our parallel sides. So JO is parallel to RK. The legs are the non-parallel sides. So the non-parallel sides would be JR, and OK. Now, our base angles, so if JO is a base, then that means angle J is a base angle, and angle O is a base angle. So angle J and angle O. And if RK is a base, then angle R is a base angle, and angle K is a base angle. All right. So if we have an isosceles trapezoid, it's kind of the same thing as an isosceles triangle, which means that it has legs that are congruent. So just like in an isosceles triangle, the legs are congruent. Well, the legs are congruent in an isosceles trapezoid as well. So in this case, our legs are going to be the non-parallel sides. So that would be BN. So BN is parallel to TM. I know y'all like this a whole lot better than trying to read my handwriting on this thing. All right, so now each pair of base angles of an isosceles triangle, so now if the legs are congruent, then the base angles are also going to be congruent. So in this case, we would say that angle P is congruent to angle E. So P and E are congruent just as they are marked in your picture. And angle G is congruent to angle N just as it is marked in your picture. Okay. And now you have one more thing that's really important about a isosceles trapezoid, and that is that the diagonals are congruent, just like in a rectangle. Okay, so the diagonals are congruent. So here I would say that RB is congruent to NO. So RB is congruent to NO. Now, they do not bisect each other, okay? That's the only difference, is they do not bisect each other. They are not perpendicular. They're just simply congruent to each other, okay? So now let's talk about the median of a trapezoid, okay? The median of a trapezoid is the line that's in the middle of your trapezoid that goes through, and what it does is it connects your midpoints, okay? It connects your midpoints. So, and the cool thing about this is the midsegment is equal to, you take this piece, you take your two bases, basically, you add them together, and then you just take half. And then the best part is that they're all parallel to each other. Okay, so they're all parallel. So DF, which is your midsegment, is parallel to both bases AL and ER. So DF is equal to, well, the only way to find that is to follow the formula. Add your bases. So I have one base that's 10 plus the other base that's 3. And all of that is going to be divided by, so it's all going to be divided by, guess what, 2. So 10 plus 3 is 13. 13 divided by 2 is 6.5. So DF is 6.5. So mid-segments, super easy. Top plus bottom divided by 2. All right, so now let's talk about kites. Okay, a kite. It does look like what you think it is. It does look like a kite. And the definition is it's a quadrilateral, has 4 sides. It has exactly 2 distinct pairs of adjacent congruent sides. And what that means is AF is congruent to AC, FE is congruent to CE. AF and CE are adjacent, FE and CE are adjacent, so therefore they would be adjacent congruent sides. So in in kite, FACE, the diagonals separate the kite. So I've got this diagonal and this diagonal, and what they do is they separate it into 2 congruent triangles. So if you look at AE, so if you look at this one here, so AE, notice you have the triangle on the left and the triangle on the right. So these 2 triangles are congruent to each other. Ooh, let's try spelling that right. All right, so I would say triangle AFE is congruent to triangle ACE. Okay, so the triangle on the left is congruent to the triangle on the right. Obviously by side, 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 because these 2 sides are congruent, those 2, and then the reflexive property for the diagonal down the middle. All right, in kite FACE, FC, so the diagonal FC, so now we're going to look at this diagonal. Notice it separates the kite into a triangle on the top and a triangle on the bottom. And these 2 triangles are incongruent to each other, but they do form isosceles triangles. So we have 2 incongruent isosceles triangles. We've got triangle AFC and triangle FCE. Now, the cool thing, the diagonals are perpendicular to each other. Okay, so all the way around we have these little right angles, just like in our rhombus and in our square. So they are perpendicular. So then that means that AE is congruent to FC. So AE is congruent to FC. All right. So now let's just go through and play with some trapezoids and some kites and answer some questions. So JO, so if we're looking over here, they want to know what JO is parallel to. Since JO is a base, then it's going to be parallel to RK. Are they parallel to one another? Is JR and OK parallel? Well, is JR parallel to OK? Well, obviously the answer is going to be no, because those are your legs. The legs are not going to be parallel to each other. The parallel sides are called our, do y'all remember? They're called our bases. The non-parallel sides, what are those sticks you walk on? Those are your legs. Now the 4 interior angles, since this is a quadrilateral, what do all the angles have to add up to? Just like any other quadrilateral, they have to add up to 360. All right, so let's get more specific and let's talk about an isosceles trapezoid. Isosceles trapezoids have very special properties. So RA, what is RA parallel to? It is parallel to DI. It is parallel to DI. And since it's isosceles, that means the legs are the same. So RD is congruent to AI. Since it's isosceles, the diagonal RI is going to be congruent to the diagonal DA. Now angle RDI, it's going to be congruent to the base angle that is on the same base. So we would say AID. So it is congruent to angle AID. And if RD, so if this is 6, so if RD is 6, then guess what? AI is also 6. So AI is also 6. Oops. Am I right with this? 6. All right. If IR, so if my diagonal is 12, then this diagonal is also 12, therefore, because they're congruent. Okay, now if the measure of angle DRA, so they're telling me if this angle up here is 143 degrees, then this angle RAI, which is the base angle that shares the same base, it's also 143 degrees. Okay, now do the diagonals bisect each other? No. All right, now here is one with some algebra. Okay, so if our measure of angle RDI is 15x plus 10, minus 10, so this angle right here, and AID, which is this angle here, we already said they're congruent to each other, so that means I'm just going to set this congruent to this. So 15x minus 10 is equal to 12x plus 5. So if I do my math, so I'm going to subtract 12x from both sides. I get 3x minus 10 is equal to 5. I'm going to add this 10 to both sides. So now I get 3x equals 15. So x is 5. So x is 5. Now they want to know the measure of angle AID. So all I'm going to do is just plug it in. So 12 times 5 plus 5. So that would be 60 plus 5. So 65. So AID is 65 degrees. All right. So that is some important stuff with an isosceles trapezoid. Now what about a kite? Okay, what about a kite? So let's go here and look at BE. Okay, since this is a kite, I know the definition is two pair of adjacent congruent sides. So I'm going to mark all this because it's easier for my eyes to see the marks than it is to keep looking. I know the diagonals are perpendicular, so all of these are 90. So now I can go through and answer my questions. So BE is congruent to EA, RBE, and RA. So is this side parallel to this side? Absolutely not. Never, no way. Okay, now what triangle is congruent to triangle RBE? So remember, this diagonal splits it into a top and bottom congruent triangle. So this is going to be congruent to triangle. So RBE is congruent to RAE. So we're going to say RAE. And BR is congruent to RA. And BA is perpendicular to RB. So let's name two incongruent triangles. So we have triangle what and triangle what. So what two triangles are incongruent, but yet they're isosceles? All right, so we have triangle BEA, which is the one on the top. And then we have triangle BAR, 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 and triangle bar, BAR. All right, so now the measure of angle R, so RSB. Well, how big is that angle? Since they're perpendicular, we know it's 90 degrees. And if BR is 13, then RA is, well, they have the same marks, so they have to be the same size. So now, if BE, so if BE is 7x minus 2, and EA is 3x plus 14, well, since they have the same marks, that means they're equal. So 7x minus 2 is equal to 3x plus 14. So I'm going to do my math here. So I'm going to subtract 3x from both sides. So I get 4x minus 2 is equal to 14. Then I'm going to add this 2 to both sides. So I get 4x equals 16. Well, 4 times 4 is 16. So x is 4. Now they want to know what BE is. So 7 times 4 minus 2. That's 28 minus 2. So that's 26. So that makes BE 26 units. All right. Last part. We're going to do some more stuff with some more isosceles triangles or trapezoids, but this time we're going to be dealing with the median, okay? So we got to go through here. AE is congruent to LR. AL is parallel to ER and DF. Okay, so I'm going to put those marks on there. AL, DF, and ER are all parallel to each other. So now, if AL is 12, okay, so remember our formula, okay? So let's write our formula down real quick. All right, so our formula, if you'll remember, is base 1 plus base 2 divided by 2, and that will give you your median. All right, so if AL is 12 and ER is 6, what is DF? So 12 plus 6 divided by 2 equals the median. So that would be 18 over 2 equals the median. So the 9 is our median. So that would make it 9. So this would be 9. Okay, well what if, so now I hope you're using pencil so you can erase this. What if ER is 12, AL is 24? So we're going to do 12 plus 24 divided by 2. 12 plus 24 is 36. 36 divided by 2 is 18. Now it would be 18. What if, don't you love that? What if they give me the middle? What if they tell me this is 14 and this is 21? How do you find this side? You use the exact same formula. I'm going to add the bases, 21 and x. So 21 plus x divided by 2. It's still equal to the median, which this time is 14. Well, remember to get a denominator gone, you multiply by it, cancels out. So I'm going to multiply this side also. So I've got 21 plus x is equal to 28. We'll subtract 21 from both sides. And I find out that the other base is 7. Okay, so you still do it all exactly the same way. All right, let me erase this so that we can do these last two problems, and then I will see you guys in class. So now, if ER is 10, so now they're saying this is 10, AL is 22, and DF is x plus 3. Now this is x plus 3. So what am I going to do now? Well, I know if I add the bases, 22 plus 10 divided by 2 equals whatever's in the middle. It just happens to be x plus 3. Well, since these are all just whole numbers, then I just add them together. 22 plus 10 is 32. 32 divided by 2 is 16. So 16 is equal to x plus 3. So if I subtract 3 from both sides, I find out that x is 13. So that would make this 16. All right, last one. Let me erase all this. All right. If angle A is 2x plus 5, so angle A is equal to angle L because it's isosceles. So if A is equal to L, then that means 2x plus 55 is equal to 7x plus 30. So let's do our math. So subtract 2x. So I get 55 is equal to 5x plus 30. I'm going to subtract this 30. And I get 25 is equal to 5x. So x is 5, but they're not asking for x, they're asking for a, so I need to go back and plug it in. So that means 2 times 5 plus 55, that's 10 plus 55, so 65. So angle A is 65 degrees. Well, if angle A is 65, then so is angle L. And the cool thing is these two are also supplementary, so that would make this 115. And this one would be 115 because you would take 180 and subtract 65 and you would get 115. So that is all for today. I will see you guys in class. Have a great one.